This is podcast 3, part of Unit 3, Household Electricity and Magnetism. And podcast 3 is on electromagnetism. There is also another podcast, podcast 4, which is an electromagnetic induction. So this is electromagnetism. Right, so everybody knows about magnets. And surrounding a magnet, there's an invisible force field called a magnetic field. It will affect every magnetic object placed in it, whether it's a magnet or it's just a magnetic material like iron. We can see the magnetic field of a bar magnet if we shake iron filings down onto a piece of paper. And you can see that you get the strongest field at the poles and the weakest field around the outside. You can see there. So whenever we draw this, we don't obviously draw all iron filings on. We just draw lines, and our lines come out the ends, and then they form a circular shape at the sides. Now sometimes we can't see the ends of the circles or the top of the circles cut off, and we just draw curved lines at the sides. Same pattern top and bottom, and the field lines always go out of the North Pole and into the South Pole. So sometimes people are inclined to go out of the north to the south and continue on round, but it actually goes from north to south at the top and at the bottom. Right, so this slide is really a repeat of the last one. Again, in what direction do the magnetic field lines point? And so what you would have there, they're going from north to south. So you can see the arrows coming out here and in here. So this must be the north and this must be the south. A few questions about magnetism. Again, feel free to stop the podcast and answer the questions. So magnets are made from which materials? Now, they're made mostly from, there are 3 magnetic elements, and they are iron, cobalt, and nickel. And most magnets will be made of iron. You will also get magnets made of steel. And steel is an alloy of iron, and there's a little bit of copper in there too. So steel is an alloy of iron. What are the ends of a magnet called? They're called the poles. What do we call the area around a magnet where magnetic force exists? And we call it a field or a magnetic field. What does the word attract mean? It means that 2 objects move together or come together. So to attract is to move towards each other. And repel means to move away. What will 2 north poles do if they are brought together? They will repel. I'll just write an R there. What will 2 south poles do if brought together? They will do the same thing. They will repel. What will a north pole and a north pole do if brought together? They will attract. What materials are attracted by magnets? So if you have anything made out of iron, cobalt, nickel, steel, and there are others called, there's one called magnedur and so on. So if any of those materials are made out of those particular elements, then they will be attracted to a magnet. They don't have to be magnets themselves. Is magnetism a contact or a non-contact force? And of course magnetism is a contact force. In fact, magnetism is actually a non-contact force. I'm wrong there, because it can act at a distance and attract things towards it. So it's a non-contact force. Now, making magnets from electricity. And this is why our topic's called electromagnetism. So, making magnets from electricity. If you have a wire and you put it into a power supply, you've made a little circuit. That wire will cause electrons to move. And when you have moving charges, you get magnetism. So that wire will have a magnetic field the whole way around it. If you wanted to look at that, what you can do is you can put your wire down through a piece of card and you can shake iron filings onto your card. And what you'll actually see is a circular pattern, like that. that's the way we draw it. You will actually see your iron filings kind of lined up a little bit, and that's a circular pattern showing the lines of force there, or the magnetic field lines. A nice circular pattern. Now we can also tell the direction that those field lines are pointed in. If you put a compass down, a compass is a little device which has got a tiny magnet in it, and the pointer of the arrow is the North Pole, and what will happen is if you put your compass down onto this, then the compass will point in the direction of the North Pole pointing. And so we can determine the direction of this by putting compasses down. This is a wire, and in this case the current is coming up out of the page towards you, and the compasses are all following each other round in a circular pattern like that. Now, there's a way of determining which direction the compasses will move or point. And that way of determining it is called the right-hand grip rule. So I'm just going to show you that. And the right-hand grip rule is used in two different ways. It's used in one particular way for a long straight wire. And what you do is you put your thumb up like this here. And when you put your thumb up like that, as if you were thumbing a lift, your thumb points in the direction of the current and your fingers curl around in the direction of the field. So if our current is moving up the way and we use our right hand grip rule, our thumb points up, our fingers curl round towards us here, so the current is, the magnetic field lines are coming round towards us like that in an anti-clockwise direction. Now, another way that we can use this is if we take our wire and we curl it into a coil. So if you take your wire and you curl it into a coil like that there, then you make a much stronger magnetic field. And we call this an electromagnet. If you can again determine what direction your current is flowing in, now I'm going to draw this a different way. And I'm going to draw it like this, as if there's a piece of metal down the inside of it. And your field lines are going up over the top of that. And you can determine what direction the magnetic field is by looking at the direction of the current in the coils. And again, you're using your right hand rule, but this time your fingers curl around the direction of the current, which is going up over the front there, and your left hand end is the North Pole. Then your thumb points to the North Pole and the other end is south. Now I'll show you what a diagram of the field lines look like in a minute. Okay, but that's how you use your right hand grip rule. You use your thumb direction of current, fingers direction of magnetic field lines. For a long straight wire, for a solenoid, you use your fingers as the direction of the current and your thumb's the North Pole. Right, so this is also called, the coil is also called a solenoid. A piece of wire which has a current flowing through it has a much stronger magnetic field around it whenever it is wound into a coil, and that's called a solenoid. All you need to make a solenoid or an electromagnet is you need a battery, you need a wire, and you need some kind of core material like an iron nail. Now, a lot of people, when they're asked this question, they say, oh, you need a magnet. You don't need a magnet. The electricity causes current to flow around the coil, and those electrons moving cause a magnetic field. So you can make a strong electromagnet using a power supply, an iron nail, and a coil of wire.